Hello friends, in this video we are going to discuss about CDMA, which is nothing but code division multiple access. So I hope all the mobile users will be knowing about technology like CDMA. So in our previous video we were discussing about multiple access techniques and we were discussing about frequency division multiple access. CDMA is also part of a multiple access techniques, but the way in which we give access to the users towards our channel is going to be different. In frequency division multiple access, so the entire band of frequency is splitted or divided into multiple smaller bands of frequency slots, and each user is going to given a minimized or reduced frequency band or slot is given. But CDMA is something like different technology where a wide bandwidth can be used by all the users, and more or less this CDMA get popular after 2000s. So we'll get into this code division multiple access. So it is a fully digital wireless data transmission system. Okay, the data what we use, maybe it may be from our natural source. It is converted into pulse, digitized, then it is utilized by the technology. So that's why it is a fully digital wireless data transmission system. It uses spatial random numbers to encode bits of information. So these random numbers are otherwise called as pseudo noise sequence codes. PN sequence. We used to know this better with a name called PM sequence. So it allows the multiple access by assigning a different user different random numbers on the same channel. So as I told you, it gives you access towards wide bandwidth, but each user is assigned to a random number. Okay, that is called PN sequence number. Okay, this is how the encoding takes place, and the user have the control of a very wide channel bandwidth over like 1.5 to 5 megahertz, and it has its own built-in interference minimization system. So this is the background of CDMA. So in 1993, the first CDMA standard called IS-95 was issued for, again this is also issued for mobile, and in 1995 CDMA technology was put into commercialization in Hong Kong and in America on a large scale. I think in April 2001, China Unicam began to construct CDMA networks. Okay, so that's what I told. After 2000, it was like kind of a golden period for CDMA phones, right? And CDMA based telecom companies. So at present, CDMA commercial networks are established in, I think, over 40 countries or area. So almost 20% of all users in the world. See, when you go to your network settings of your mobile phone, you can see something like WCDMA. And when you have a mobile phone, like you bought a mobile phone around 6-7 years back, then you can able to see something like CDMA 2000 and all that. So this is the little background information about CDMA. Now we'll see what this actually works, how it actually works, and what is this technology is all about. So CDMA stands for, as usual I told, it is like a code division multiple access. It provides a new dimension which represents the code. Okay, see in FDMA it is all about frequency, in TDMA it's all about time slots. Okay, so it had its own problems like it need a linearity, and it will never work with non-linear like environment. So a lot of restrictions are there, and in terms of bandwidth also we have a lot of constraints, and in terms of number of users also we have a lot of constraints. But CDMA is altogether, it's a different technology. So it works in two methods, which means like it adapts, right, two wide bandwidth modulation techniques. One is called frequency hopping spread spectrum, and another one is called direct sequence spread spectrum. So what happens here is your digitized data, right, from your source is been spreaded to a wideband modulation, and the spreading of each user data takes up a identification called a number or code. Okay, that's what is called random code given for each user. One thing about your PN sequence code is nothing but these codes should be it should not have like too much of correlation. Okay, it means what the code should be distinct for each user around the same area. So this huge application in cellular network has happened. We all know this. So there are three varieties like as per the evolution. So it has started, it's all started around 1993. So the first standard was commercialized at 1995. That's why it is IS 95 is the first standard. Then around 2000 we had CDMA 2000. Right now we are using WCDMA for 3G. Okay, so in your mobile settings, if you go there, right, so we have options. So we have 2G options, which is working on top of GSM, and we have 3G options, 3G, or even we can say 3.5G, which is working based on WCDMA options. Okay, and also soft handoff, it is actually increasing the reliability of handover. So we know what is, I guess we know what is handoff. So when a user is migrating from one particular tower to another tower, right, so the control, the entire control is being transferred between one, like base station to another base station. This particular process is called handoff. When this affect your like signal quality, then it is called hard handoff. If nothing happens, then it is called soft handoff. Okay, so now we'll see what we are going to discuss here. So we are going to discuss about CDMA and how it works, and the types of CDMA, what are the advantages, and what will be the applications of CDMA. So here the basic about CDMA is this. So what we have here, so we have time, we have frequency, and we have code in the 3 dimensions. So each user is given the entire band of frequencies to access, and the time is there. But each user is identified based upon the code. So you can see here the wide band of frequencies what we can access here is like around 1.25 megahertz till 5 megahertz. So 1.25 megahertz is for IS 95 standard of CDMA, and 5 megahertz is for wide CDMA, that is WCDMA. Okay, so so now, so there exists a new dimension over, as I already told you here. So code will be the new dimension. So each user is given with a code. So the representation of the user is going to be code. Okay, so how it works, very simple guys. For example, I am having 10 users and my entire band of frequency is 100 megahertz. So I'm not going to split these frequencies. Okay, instead each user is given with a random code, so that all my 10 users can able to access my frequencies or access my bandwidth. So now this is the working principle of CDMA. So CDMA transmitter. So what functionality is done by CDMA transmitter, we'll see. So the voice has to be digitized. So what we use general, right, will be pulse code modulation. So you might have studied this in digital communication. So pulse code modulation, so it is PCM. I think you may going through about PCM in unit 1 or unit 2, I guess. So pulse code modulation is the very widely used standard modulation to digitize. Okay, so as I told you, the CDMA supports completely digitization of wireless data transmission. So the voice has the voice has been digitized. Then each user is given a unique PN code. The code must have low cross correlation, as I told you. The correlation, yes, cross correlation must be very low. It means what? You take a area like Chennai. Okay, in Chennai I have Tambaram area. So there are CDMA infrastructure is there in Tambaram area. Means what? All the Tambaram area users code should not be correlating. Okay, should not be correlating too much. Okay, so the code should be like unique. Okay, and the relationship should be very less. Okay, that is what is the meaning of this. The transmitter it multiplies the code by the data to get the encoded message bits. This is how it happens. See, we have digital data and we have the code, it is multiplied, and then we are getting the encoded bits. This is how your CDMA works, and this is the diagram of CDMA transmitter. And you can see here different types of data we can get. So digitized voice data, ISDN, that is nothing but integrated services data network data, or other data, any data, right, which is in digitized format is taken into CDMA transmitter input, and you can see after that it's a digital data. So a very important process of CDMA is called spreading. So it uses 2 types of spreading. One is frequency hopping spreading, and another one is called this one, direct sequence spread spectrum. So there are 2 varieties. So for both spreading concepts, right, the reference is going to be from PN code, okay, which is generated by a PN pseudo noise sequence code generator. PN means pseudo noise code. Okay, so it is a random code which is generated by a device called pseudo noise sequence generator. So after that it is a spreaded data. Then it is modulated as usual for data transmission over wide area or longer distance or whatever it is. Depending upon my necessity, I am going to do the respective modulation. So here RF modulation is happening. So yes, analog. So RF modulation is happening. then it is given to the transmitter to transmit the data. So this is how the CDMA transmitter side works. And now we can see the working principle of CDMA, under which we can see this spectrum of CDMA. So you can see here, right, in the x-axis you can see the code numbers of the users, and I think in y-axis it is going to be, yes. So you can see here the chip duration is like 0.4 milliseconds, and you can see different colors. So green color is the message, red color is like spreaded information, and that blue color is nothing but noise. Okay, and you can see a gain of 1, maximum gain of 1. Okay, so this is how spectrum of CDMA will look like. So you can see there is a standard chip duration, and there is a bit duration, that is 64 milliseconds, and a processing gain is going to be 16. So for this particular case, and you can see how the entire band of frequencies is spread between 5 megahertz range. So you can see here in x-axis, so I have frequencies up to 5 megahertz. So receiver side working principle, so the received signal is multiplied again by the same code. See, in both the cases between the sender and the receiver, you must use the same pseudo random noise sequence code, otherwise we cannot able to decode the data. So what we are actually doing is we are using the same PN sequence code. It is multiplied again, and it is integrated over the bit duration. Okay, for example, here in this case bit duration is like 64 milliseconds. So same bit duration is used and it is integrated. Then using a hard decision method, the transmitted data is decoded. Okay, so this is the again receiver arrangement. You can see we are getting the received signal, right? Again analog signal which is received by my antenna, and then it is processed. RF demodulation has to happen. Then we have the data acquisition unit and PM code. So the PM code is again integrated for despreading purpose. So we have digitized data on one side, another side we have PN code. So both are integrated to perform despreading operation, and finally we can restore this data. So this is how your CDMA receiver works. And types of CDMA, as I told you, there are two types of CDMA we are actually using. One is for frequency hopping spread spectrum, and another one is like direct sequence spread spectrum. So in frequency hopping spread spectrum, the fixed sequence of frequency values and times are divided into slots. So the frequency is like a kind of hopping frequency generated from different users. So in the first time slot, a given user transmit to the base station using the first frequency in its frequency hopping sequence. So there is a frequency hopping sequence. So I am the user one, I am using my first time slot, right? In the next time interval, okay, it transmits using the second frequency value in its second hopping sequence. So I generate frequency hopping sequence based upon the sequence and time slot. I am actually transmitting data from different users. This is one way. And the another way is called direct sequence spread spectrum. So each user transmits its message to the base station using same frequency at the same time. So here the signal from different user interfere with each other. So that is one thing to be considered. But the user distinguished in the message by using a special unique code. So this code serves as a special language that only transmitter and receiver understand. It's here, it is very simple. So what we do, you do the spectrum spreading with the help of the random sequence code in the direct sequence method. But in the frequency hopping method, you create a hopping pattern. Based upon the pattern, you send the user data. This is how CDMA works with frequency hopping, and this is how direct sequence works. And finally, the application. So IS-95 is a standard, first CDMA standard, so which is used in USA, and which was standardized during 1995. So the basic data rate is only 9.6 kbps. The chip rate is 1.22, m chips per second, and the allocated bandwidth is very less, 1.25 megahertz. So there is a fixed spreading code of length, only 64 is used. So CDMA 2000, I hope you will be knowing this. Okay, in India after 2002, I guess the CDMA phones got a peak market. So we all know about CDMA phones after 2000. So it uses a standard called CDMA 2001X is the first version, and it uses the same 1.25 megahertz as IS95. There are versions with CDMA 2000, and there is a second version. So in the second version, the data rate is improved up to 2.4 Mbps, and applications is like MP3 transfers and video conferencing can be done. So CDMA version 3 is 1x EVDV. So here uh, we can do voice as well as it will be like supporting integrated services with high speed. So the packet data multimedia services can be like ran up to 3.09 mbps, so the speed will be like maximum of 3.09 mbps. Okay, so here WCDMA, so this is what we use today in our mobile phone. You go there in your network settings, you can find WCDMA as a 3G technology. Okay, so you can see faster chip rates of 384 M chips per second, and the maximum bandwidth is like 5 megahertz. So the wider bandwidth, so that greater frequency diversity. Yes, like we all know about this. So data rates, yes, it's up to 2 Mbps of packet switched network. Okay, which is nothing but like what we use in our day-to-day life. Okay, so packet switched data, IP data. For IP data, we will be getting 2 Mbps of speed. Okay, so this 2 Mbps is as per the 3G standards. Okay, and finally advantages. So the capacity of CDMA is big, so it is going to provide you better capacity, and also more like user bandwidth can be done. And the when I compare this with GSM, which runs based on frequency division multiplexing, it is 3 to 5 times better. Okay, and CDMA consumes less power, coverage is going to be like large areas. So when you take about the cell structure of your mobile, base station, then definitely it is going to cover a larger distance. So CDMA is able to produce a reasonable call with lower signal levels, and CDMA uses soft handoff rather than hard handoff, so that the likelihood of dropping calls will be very less, and it is going to have a well defined higher data rates. Okay, so when it comes, we are talking up to 3G standards. So for a 3G standard, when it comes to packet switching, 2 Mbps is better one. So that is what we can achieve from CDMA. So these are the advantages of CDMA. So yes friends, with this I think CDMA is over, and thank you.